Okay, hi everyone. My name is Winston Wong. I'm the Partner Alliances Manager for Australia and New Zealand, and I'll be your host for today. I'd like to start by thanking you all for joining us today for our webinar on Accelerate Transformation with Terraform on AWS Landing Zone, which will be presented by David Wright from HashiCorp and Welly Siauw from AWS. So today, Dave and Welly are going to discuss the value of using Terraform on AWS Landing Zone to help customers provision infrastructure in minutes and set up a secure multi-account AWS environment based on AWS best practices. Before I pass over to Dave, I'd like to go over a couple of housekeeping items. First of all, I'd like to note that this session is being recorded and the recording will be made available within a day or two. So we will email that out to all of you. Secondly, please submit any questions you have throughout the session via the Q&A tab. Dave and Welly will answer them at the end of the session, so we'll come back to that. So with that, let's go ahead and get started. Over to you, Dave.
Hi, thanks, Winston. Big appreciation to Welly for helping me with this. In today's presentation, we're going to talk about a few concepts that stitch together that tie into allowing an acceleration transformation. So first, we'll look at some of the history of where we've been, build out some of the history of the why, and then look at the how. So how do we then tie a solution together? What are the key components? And then in our demo, we'll work through and look at some of those practical implementations of those hows. And so hopefully there'll be plenty of stuff for you to cover off. And as Winston said, please feel free to ask questions using the Q&A, and we'll try and get to them at the end of the session. So if we just take a small step back and think about where transformation has come from and why it's important. A lot of that is set around process and how we used to do things. So I know from when I first started in IT, everything was ITIL based. And in that process, you would see a developer or either another team ask for a piece of infrastructure via that ticketed system. That ticket would come in, I, as an infrastructure admin, would pick up the ticket, and then you'd start to look at what was needed. That could be, I need to physically build some infrastructure. I may need to get new switches, I may need to get new hardware, I need to rack it. It may be that there was a security policy that had to be changed, maybe firewall changes, routing changes, any of those actual physical elements. Tying that into a BAU. So is it part of a standard business as usual operation? Was this a specific project? Did it have cost coding? And then once all of those decisions were made, we then got into the pets scenario, where the infrastructure then became who's going to support it, how long is it going to be supported for, is it included in that backup cycle, is there support on this? And all of these things and decisions had to be made before we then fed that back into a completed work ticket that went back to that software developer. And I know from my own personal experience, I had a project that once dragged on for 6 months whilst we were waiting for a particular server rack to come in. That rack of equipment was from the US. It took us that long. And so therefore our project was delayed by that 6 month period. And of course, at the moment, with chip shortages, a lot of actual hardware elements are taking a lot of time to actually be deployed and showing up. So this process is still very common. It still uses and eats into a lot of time. And so with the likes of AWS coming on board, with the likes of cloud becoming more prolific, so this concept of creating an API first, an API driven environment becomes very to the fore. Infrastructure as code is the ability of organizations to create and write code the same and using the same techniques as they have and the developers have in the past. So we start to think about having a single source of truth. So we have our version control that we write code to and actually use that as a central repository for all of our stored code. That means that now there is versioning and the ability to collaborate across that environment. Also the ability to be able to roll back, see what changes were made, all integrated into that standardized code writing practices. Implementing this and having an infrastructure as code approach means that your infrastructure is now defined in that code set and can be rolled out repeatably and quickly using infrastructure as code. So the whole infrastructure as code process becomes highly important in being able to actually implement and drive an accelerated transformation. Without that thinking and without leveraging and positioning infrastructure as code at the core of your process around your digital change, it's going to be really hard to actually find the acceleration and deliver the promised outcomes that you want through your transformation. And so how do we stitch those two things together to really kind of define what the modern application integration is? Well, at the heart of it, we have our version control system. And so in that becomes our single source of truth. And then we build that into a pipeline environment. So that pipeline could be something like code commit, or it could be any of the other open source tools that you are looking to drive that repeatable workflow or pipeline driven workflow into. And so we now have our developer and our automation team working together. They both write code and commit that into our central version control, so our single source of truth. And then those changes or those builds and that commits can be used to actually trigger and deploy Terraform and infrastructure. So if you're leveraging Terraform Cloud, for example, and we'll talk about that more and look at in the demo. If you're using Terraform Cloud, that then now pushes a trigger for Terraform to stand up that infrastructure as that infrastructure builds through, so you can inject secure keys or key value pairs into that build pipeline. So now you're incorporating a security best practice into how you drive your infrastructure and also your applications. Once that infrastructure is stood up, you now have an environment that is automatically ready for you to now actually push that application down onto, stand up, and now you have a total environment. Obviously, this now means that you can do this repeatably and through different environments throughout your business and in a collaborative way. What this is leading to is that HashiCorp has a set of tools that will help you in all of these different stages. So for example, as you go through that build pipeline, we have Vault, which can be our secrets management to allow you to push secrets into that pipeline and leverage it across your application. Obviously, a lot of what we're talking about here with infrastructure as code, Terraform obviously helps you really allow you to do that as our infrastructure as code tool. But also some of the other projects that we have within our toolset, like Packer. Packer now fits within our HashiCorp Cloud Platform, so HCP, and that Packer element can now be used to create golden images, again fitting into that pipeline workflow where we create standards and repeatability. So now we have a baseline image that is secured with automated or dynamic secrets that is being driven by infrastructure as code that then can be connected into different environments leveraging Consul. And so we're seeing the tool set come together as this single control plane to be able to drive platform consumption, and that platform consumption could be purely cloud, so digital native, or it could be in a hybrid situation where we know a lot of applications are still going to have a heavy on-cloud, on-premise component that needs to connect into that environment. And so leveraging an automated or single process, particularly with Terraform, which allows you to have communication across any platform, means that now you have that singular tooling, singular control plane, automated delivery to actually drive your digital transformation. And so all of those things fit together to mean that automation is key to unlocking how you can work across in a collaborative manner. And so we'll take a look at this in some of the modularization with demos. But uh, what this means is now that you have adopted your infrastructure as code approach, obviously within that structure, there's going to be different teams, there's going to be different spans of control, there's going to be different skill sets. You know, the networking team are going to understand how to do some of the physical routing and networking. You're going to have your database team that are going to want to be able to say, well, this is how you do scheduling and backup times and optimization around data. There's going to be your actual apps team that are going to say, this is how I want this to actually look and feel, use cases. And so how do you stitch all those elements together to, at scale, to now drive those outcomes? And this is where this approach around tying all of these elements together, having your pipeline, integrating an infrastructure as code tool, being able to apply standardization and repeatability into these different modules. Now, each one of these different lines of business can take responsibility for it, create a module. So that module fundamentally can have the repeatable elements within it. They can then publish that as a usable golden standard that then other teams can then consume. And within Terraform Cloud, you can actually tie workspaces together, again, as part of that pipeline and workflow, where once one area is built, you can then trigger a subsequent build. So you can start to tie these things together so that you get your workflow outcome. And this is where Terraform really has a different approach in thinking about the overarching workflow. That workflow is the collaboration of different workload specific elements. So each cloud platform or different platforms are going to have very workload specific criteria. That could be the networking way it's set up, it could be a particular service. That is just an element that fits within the overarching workflow. So the workflow you're driving within Terraform Cloud is looking to deploy the outcome, so the application that you want to stand up. All of these workload specific elements or business unit specific elements can fit into that and tie together leveraging Terraform Cloud. And so a lot of what I've spoken about is the elements around creating repeatability. And repeatability comes in many different forms. Obviously, landing zone was a term that was used within AWS, quite heavily. That's now developed into thinking around different terminology and different concepts. But fundamentally, a blueprint is that element where you create a pattern. That pattern can be reused, and that pattern allows you to then stamp out that same thing over and over again. And that leveraging that thinking into your transformation, as opposed to writing code that allows you to obviously gain velocity because it's quicker and writing changes, but it has still a singular content in its delivery. I wrote this code if it solved this specific problem, and then I went on to the next project and I wrote almost the same code again to fix their specific content. And what we're talking about with leveraging blueprints is just thinking about how you can look at that code sets. And if you're doing or having to repeat that more than 75% of the code, then you should extract the information or the variables and the specifics out of it, which we'll take a look at in some of the demo, to make sure that you then have this reusable content and golden standard. So where has this been done? So we've seen more and more customers and more of our partners starting to look around how to create and formulate repeatable modules to allow them to get things done. I've had conversations with our own partners where they use this concept to actually build up and stand customer environments. So they walk into a customer, the customer says, I want to move to AWS or these workloads, and the partner can then say, we can use this mechanism to allow for meeting the well-architected framework. This deploys best practices. We can then lay in some of our industry specific knowledge, stand that environment up, and then in a very short period of time, establish what the customer needs. And a lot of that is being based around that Hashi stack. So that Hashi stack becomes that control plane or singular point of control across as tools to allow those tools to then drive and establish the best practices across that framework. And tying these two elements together with creating golden templates and or golden patterns, creating golden standards and modules you're leveraging Packer, creating a golden module that you can use, means that a lot of the criteria, particularly in terms of getting sign off and getting different business units to agree that this is what I want to be used, also pushes the boundaries or allows them to actually use those and consume them in a repeatable pattern. And so some of the great work that we've done together with AWS is looking at how we can actually accelerate and provide a better experience for our customers. And so one of the things we've done is built leveraging Terraform, and Welly is going to be kind enough to run through deploying one of these as part of the demo. We've built out a set of patterns that stand up common criteria that we think customers are looking for. There's also a best practices VPC one, which I think is the one that Welly will actually demonstrate. And we've put these building blocks there to allow customers that ability to take these patterns off of what we see as best practices, customize them into what suits their environment. So again, being able to leverage that pattern-based and repeatability, tweak it to suit your environment, and then get you going as fast as possible to stand up and stamp out these repeatable elements. And these can then be written or have been written in a way that they can be stamped out and used multiple times. Now, all of that kind of elements go towards helping accelerate, but as you get faster, one of the things you obviously have to think about is how you can do at speed, but make sure that you're still matching or meeting your security requirements. Because there's no point being really fast and deploying lots of things to then have to spend loads of time to go back and secure them. And so to do that, Terraform Cloud obviously has this really powerful feature called Sentinel. And Sentinel is our ability to write policy as code. So tie in again that as code approach. So we can define our infrastructure as code. Now we can define some standard security policies that allow us in between this is what we're going to build and this is what we're actually going to build through that plan and apply process. We can validate a whole bunch of security and defined elements before it goes before it goes into the environment to be stood up. Now this isn't proactive security. Once it's built, we don't actually then continually monitor it, but we do allow for things to make sure that best practices are being applied. A great use case that I have heard was in a dev test and production environment. They actually use Sentinel policies as it went through the 3 environments to enforce best practices. So there is a CIS, so Center of Internet Security library that we have built a whole set of policies around, and they use those to actually enforce standards within the developer community as it moves through those different environments. So if the developer didn't use or meet CIS at the very first attempts to stand it up, they couldn't push the environment into the dev environment, and so it forced them to write better code. And I thought that was a really interesting use case around using security to actually to educate and improve. Another interesting thing and collaboration that we've done with AWS is obviously, as we have an API first world, we need a mechanism to be able to communicate and understand what that API is. And Terraform does a lot of that heavy lifting for you. But there is also, and Welly will touch on this, there's also different ways to talk to APIs. So as the language of API becomes more complex, and as AWS continues to expand its services offering and drive best outcomes for customers offering as many services as possible. So trying to keep up with those API standards and API call structure has become complex. And so to try and simplify that, we've actually introduced another provider, which is the AWS Cloud Connect provider, so CC provider. And Welly will touch on that a little bit later. So the last part of stitching this all together is then, so we can take these obviously this heavy lifting, a lot of work has been done through modules or repositories or repeatable patterns, and then how do I actually use that as my golden standard? So within Terraform Cloud, you have the ability to ingest into a private registry, and we'll take a look at that and how that works to allow you to actually then point and share specific golden templates across your environment. And so at this point, I'm going to switch over to the first, or walk through some of the demo elements. So the first thing, obviously, I've spoken a lot about is getting Terraform Cloud, or talking about this from a Terraform Cloud perspective. Now, for everybody or anyone that hasn't got a Terraform Cloud account, then the easiest way to do it is to go sign up. It is free. You get a free tier. You can use this will basically manage a lot of your state. It can take control of a lot of the basic concepts. Once you have signed up and log in, you also have the ability to upgrade to a free trial. So you could try one of the business tiers or one of the trial plans, which will give you the governance and compliance. So that allows you to run a similar set of or the similar functions that I'm going to demonstrate here. So you can just try the free trial plan and you'll be able to run these similar examples. The code is available and out there, so you can actually definitely follow up. So now we have our Terraform Cloud, which gives us the element of giving us the pipeline mechanism. So the first part of our how that we talked about. So this is giving us that structure around the right tooling to do this. Then we look at our code sets, and now thinking about our code, how we write our code. So how are we creating those golden standards and modules? Now this is an example of the code set, which is open source, so you can clone this and download it. This is the main file or the main sheet that will run and stand up a best practices VPC. And in this, you can see we're calling our provider, so how we talk to our API. We're defining a random resource. So obviously, again, making this code set repeatable in the fact that it can be used multiple times. It will create a random name. No resources will clash. You can define a prefix with it. So obviously giving it a certain degree of control so that you know exactly what it is and all these infrastructure elements. The other thing that I'd say is you could also add into this you can add into this is then defining your tags. So obviously getting default tagging into this into your environment as soon as possible also helps track and control cost and infrastructure expense. And then within our top sheet, we now have an abstraction where we're just calling the pieces that we need to define. So for a developer or someone, then it's very easy to integrate just the necessary information, simplified down that module, which has all the best practices elements into it, and just give them what they need to define. Now this could even be set. So in this case, these are the default networking that will be used, and every one of these that would stand up a VPC would have a separate name, a random pack name, and use that same environment. So it could be that you could even simplify it just down that you can give this as a best practice to another BU to use, and they could actually start to draw through and actually leverage and reuse this. In this criteria, you can see if we look at the Bastion host, this is where within our module, so in this structure, we have our main top sheet and we have our modules being called locally within that directory structure. So again, within best practice, putting in the overarching elements that allow us to then call those modules. So we have the modules repeatably. And in this is then all of the specific criteria around creating that workload specific content. So again, this is workload specific. And at the top sheet, we're modularizing that to make it as repeatable as possible. And the way that we do that is making sure that our variables are defined within that criteria, and they are unique within the elements that we can then tie back to our top sheet. Anything that we want to expose to the user to reuse, we then include in that modularization for them to customize. So now if we just take a look at how do we implement that security part. So if we go to our workspace, this is the workspace I'm using. Within this environment now, how do we apply that security element? So this is from our Learn guide. So you can actually go to our Learn site and actually follow along and write this code or repeat this demo yourself. So one of the great things about HashiCorp is our great open source community that supports a whole bunch of stuff and the amount of information that we put out using our Learn. So what we've done here is we've tied this workspace into a particular VCS. I've got VPC on the head, and this is then going to allow us to run some code. So what we do when I kick this plan off, just so that we can get going, you will see that this will actually now go into a run through a plan. And so as this is planning, as we run through that plan, you'll see that, well, hopefully you'll see that the resources, it will decide what it's going to create. So it's going to define these outputs. So it's going to say, I'm going to build these instances. It then goes and does an interesting thing. So I have cost estimation enabled for this environment. And so in here, you can see that it's going to run this Ubuntu instance and come up with a monthly cost for that. What I have also done is associated a policy, and we'll take a look at that in a moment, where we can tie that in. That policy is then checking to make sure that the cost of it is less than $100 a month. And so now we're again at that point of within your workflow, gives you the ability to actually put some best practice control around your automation, but make it so it's seamless so that you as a customer can deploy as quickly as possible. Now there are 3 stages within a policy that can be enforced. There's advisory, kind of self-explanatory. There's soft mandatory, which means for me to be able to deploy this or continue, I would have to press and override this. So anyone with the correct permissions could actually confirm and apply that. Or there's hard mandatory, which means that the run would effectively be stopped and discarded. It's like so. So within this element, we go into settings and general, and in our in our settings, we go into our policy sets, and here you can see we have our policy set that is then now tied to a specific workspace. So you can start to use your policy as code tied across different workspaces. You can repeat them. You can apply it across all workspaces if there was a particular policy that you wanted to do. And all of this is being driven out of your VCS connection into that environment. And so now we have, we set up our workflow with Terraform workspaces. We need to think about security. So we've implemented security into our workflow and how we can put some control and governance around that. Then the next stage that I talked about in that, how do we create those repeatable elements? And so within Terraform Cloud, you have the ability to create a registry. Within that registry, you can bring in modules. So for example, in our demo, we've pulled in this module. So this again is from the Learn Guide, and you can see that we can see there's some inputs that we need to define. It has an output that it will define. we can actually go into the actual specific code. So if we went to our repository, you can actually go and see the code set that is there. And here we have the actual code that is being used and deployed to create the environment. So now that we have this, the other really good thing about implementing this and pulling it in locally is your module actually tells you what you need to do to actually deploy it. So now you have a mechanism to be able to use this locally as that point of reference. So before I move on, one thing that obviously you can do that is a very useful way of being able to find things quickly is, what if I wanted to leverage a provider or something that's out there? Oh, look, here's the AWS CC, which is that new provider that I spoke about, and we want it to add it into our organization. And as easily as that, we've now added that into our providers. So now we have both our providers that we could leverage. We could reference these locally. We can call them and customize them if we needed to. We can also ping these, so you actually have versioning pins. So if your workspace or your code set behind that is tied to particular versions, you can pin them to that module, and now you have control over which version to run, and make sure that you have that continuation of code and versioning as you run through your deployments. So let's have a look at how or what that looks like when we actually want to deploy a module. So if we just take a quick look at our code, this is now our code that we will run. And now think about this slightly differently, is this is the code that we're going to run within our Terraform Cloud element. And it's our module. This is our module point that we are imported into our registry. So we're saying, I want to run this from the registry, and I'm going to pass these variables to that workload specific context. So if we go back to just into our workspace, we've defined our variables. So here we've defined our variable name, a prefix, and a region, and we've imported some our AWS session and token keys within the environment. So I already imported that just for time. So that's our unique. So if we now wanted to run this plan now kicks out, runs through quickly. It was quickly when I did it before. There we go. And this is actually going out now, pulling and talking to that module registry, pulling in the elements that it wants to build out. You can see it's going to give us an output of an endpoint. I can now confirm this, so I could give this some sort of relevant information. Let's call it build 1.0. We confirm that plan, and our infrastructure now is actually being stood up. So again, when you think back to our original how and what we're talking about, this is creating you, or the ability to create that workflow. We've now templatized that into a way that is highly repeatable. Oh no. Typical. There's the demo gods for you. We have we've built that repeatability into the code set. We have used that and implemented security, and then we have leveraged the internal or golden image that we've created within our environment to then actually deploy that into our own environment, and reusing that as a point to stand up. And so now what I'll do is I'll hand over to Welly, who will then walk through how to, leveraging that same thinking and that repeatability, you can deploy those AWS patterns that we talked about that will allow you to actually have a workload specific criteria. So I will stop sharing and pass it over to you, Welly.
Yeah, thanks, David. That's a great demo right there. Looks like got some service limits with the bucket. Happen always. Yep.
You should be giving us free You should be giving us free buckets. We need more.
Yes, indeed. Like, because I'm sure you have a lot of buckets right there to hit that limit. Great. Yeah, so I want to continue from where David mentioned earlier about the deployment, specifically like how this deployment works with Terraform Cloud. So in my demo, what I'm going to do is that I will show you how I use the Terraform CLI connected to Terraform Cloud, and then use this Terraform module from AWS IAA, and we will do the VPC deployments. So a little bit more maybe about what is AWS IAA or integration automations. So this is an effort jointly developed by AWS and also working very closely with HashiCorp in here. And then a lot of the modules that we built in here under the AWS IAA is designed to be deployed, of course, in the Terraform Cloud. And it's built as like foundational building block, essentially. So again, coming back to what David mentioned, repeatable patterns. Terraform module by design itself is opinionated in a way, right? So you can always build your own using this as the building block and kind of adopt it into your own private module, for example. It's open source under Apache 2.0, maintained by AWS, of course. We welcome your contribution as well. So if you have any ideas how to improve these modules, we certainly welcome that as well. And want to quickly mention about AWS Cloud Control that David mentioned earlier, so AWS CC. So a couple of the modules that you see in here are starting to use this AWS CC provider. If you kind of hear and see, like maybe just like last year reInvents, we have AWS has like 200 plus services, roughly about 2,500 new feature and functionality that we released just last year. So keeping up with all of those definitely take a lot of manpower, and we have a great community that does that. Where the AWS CC is taking a different approach is by automatically scanning through the schema itself and generating those resources and feature for you. So you typically can start using AWS CC, you know, on the day when the feature is launched, and maybe a couple of days afterwards. I recommend to take a look into it. It's still on technical preview at the moment. We are looking for a lot of feedback from the community of how you want to see the AWS CC looks like. Right. So now coming back to the demo, I have my IDE in here, and I already have my Terraform PPC. This is the module itself under the AWS IAA, and I just clone it. So you can see in here, I clone this repo, and I have it in here. Let's have a quick look into what is the content of this AWS VPC module. A couple things that I really like about it. First, as I mentioned, it gives you some instruction how you can deploy this using using the Terraform Cloud. So you can see in here, there's a couple instructions how to do that, how to deploy this into a Terraform Cloud. So that's exactly what we're gonna do today. So I have my Terraform already running on my Terraform CLI. So first thing I want to do is to connect my Terraform to Terraform Cloud. So to do that, I'm gonna do Terraform login. And in here, I will say yes. So what this is gonna happen is that I'm gonna redirect myself to the Terraform Cloud, create a new token, and that token will be stored in this credential file in here. So any of my Terraform activities gonna be connected directly to Terraform Cloud. And just like Dave, I already have my Terraform accounts in here. I have a couple of organizations gonna use these organizations in here as part of the demo. So let me go and click on that link. I will open this, oh, sorry, different one. This is the one. Okay, so I will use this and maybe move it to the different window. This is basically gonna ask me to create a token and then store that token into the directory. So for that, I'm gonna do it on the different window in here. Great, all right, so I got my token created already. So you can see in here, let me just move it again. That's my token, just created a couple seconds ago. So I'm all set with that. And now, since I have that token, what I'm gonna do next is to copy that token and then store it in the CLI. So let's do that, move it in here. Not gonna see it, but that's basically connected me to the Terraform Cloud. So first step is done. I got my CLI connected to the Terraform. And outside of Terraform Cloud, I'm going to create a workspace like what they did, and then use that workspace to deploy the VPC. So again, what I like about this module in here, it's how simple it is to use the example to deploy the Terraform workspace. So now I'm in this directory where I have my workspace set up. So I just need to run Terraform apply. There's a couple of credentials that it acts like AWS credentials such as access key and secret key. I have like a variable files where I store that. So I'm not going to show it to you, but then basically in here, I'm going to do Terraform init. Let's just pull the module and then Terraform apply. And in this case, I will use that variable files that I have. So that will include like my credential. So the only questions this Terraform CLI will ask is about my Terraform organizations, which is in your case, you're going to use your own Terraform Cloud organization. I have mine in here, which I will use. Go. So it's going to ask me the typical dialog for yes to deploy. So now this will create the workspace. Okay, so this workspace will be visible very soon in my Terraform Cloud. So there you go. This is my new workspace. I'm gonna copy this. And let's just have a quick look at the Terraform Cloud. Jumping in here, and let's search for that particular workspace. Here we go. A couple of seconds ago, my workspace is just created. There's nothing in here yet. We haven't deployed the VPC, which we're gonna do next. But a couple of things I really like about Terraform Cloud, for example, with using this provider for Terraform Cloud, when I create that workspace, things such as my variables, files, and my region and everything is already injected in here. So then I don't have to worry about that pieces anymore. Okay, back to my IDE. I get my workspace set up. Likely for this particular module, there's also an example actually how to deploy this. So here's on the deploy directory. I can see this is some example of how I can deploy this module, right? So this is a great way for me to get started quickly and use the module. So I'm actually gonna do that right away. The other magic thing that happens when I create that Terraform workspace through the CLI is that it creates this backend file and put it into the deploy directory. So now this Terraform is connected to that workspace that we just created, and also like the organization. So the host name, because it's Terraform Cloud, so it's connected to the Terraform Cloud in here, and my organizations. So what does this mean? For me, it's gonna be as simple as running Terraform apply. A lot of the variables like a CIDR range and etc. is already pre-populated. So now in here, basically you can maybe start noticing if this is first time for you to look at Terraform Cloud, we're gonna prepare for remote apply because the apply is actually happening on the Terraform Cloud instead of local in here. So here we go. So all of resources has been built. If I'm looking back to my Terraform Cloud, if you look at the runs, there you go. So that runs is actually triggered by my CLI in my IDE, but it's now running on the Terraform Cloud. So I can use this friendly view in here and see basically the same thing that I saw on my CLI here, right? Dave already mentioned about the cost estimations. I also have my Sentinel policy. So maybe quick look into that. So in this Sentinel policy in here, I have a very simple checks just to check for the Terraform version in terms like the Terraform binary version that I use. And it's a self-mandatory checks, but it's resulting it's true. So this is again a way for you to put the enforcement or the governance as part of your Terraform apply. So now, just by selecting yes, I will finish the plan, check the Sentinel policies, everything looks good, and now we run the Terraform apply. In the real world scenario, of course, you're working with the team, right? So instead of having your Terraform sitting on your desktop workstation, for example, using Terraform Cloud so you can collaborate within a larger team, I really like that because someone run the Terraform apply, I can have a team member looking at it. I can see how that policy check looks like, for example, and also the result of the apply itself. And the state file and etc. all is managed by the Terraform Cloud as well. That's also another things I really like because now everything is securely managed. You can define who have access to those this workspace, and also means like access to the state, and it's all highly available as well because now you are storing those in the Terraform Cloud. So while this is still running in here, it will take maybe a couple more minutes before it's finished. Maybe you have a questions about what is this policy looks like. So real quick, back to what Deb shown earlier. If you look at the policy sets, get my, I have two policies. One is cost estimations, just like what Dave have. The other one is for enforcing the Terraform version policy. It's also connected to my repository. So again, the demo I'm showing today, I'm going from my IDE directly, downloading the templates for the Terraform VPC module and then deploy it. In real world, you probably connected that to the VCS as well. But super quick, just a couple seconds. If you are familiar with like a regex matching in here, this is basically the Terraform, using Terraform plans to check for the versions, any version above 0.14 and 15, or any versions above 1.0. So essentially, that's the sub-mandatory checks that runs as part of the apply itself. Okay, so still a couple more minutes for this to run. Don't want to hang on because I think we have a couple of good questions come up as well. But that's pretty much kind of conclude my demo on how to apply the Terraform through the Terraform clouds, and happy to answer any follow-up questions. But before then, Dave, I'm gonna hand it over to you. I think you have a couple call for actions as well. Looks like, were you on mute, Dave?
Bam. There you go. Thanks, Will. So what we have next is obviously, some great examples. If you go and take a look at that link, there's actually a whole bunch of modules that the teams between HashiCorp and AWS have actually built and deployed. So there's a whole bunch of stuff in there, things from Fargate through to transit gateways. I think there's Express Route in Route 53 in there. There is a whole bunch of other elements. I think there's an account element in there as well, if I remember correctly, isn't it, Will? I think there's a how to do cross account setup as well in there. So there's a whole bunch of really useful resources. Please go and check it out. They will help you in your building and repeatability and transformation. So that's an important tool to go and look at. On the learn side, there is some learn guides around how to get started on AWS. That also walks through how to get started onto Terraform Cloud. Like I say, go and get yourself a free Terraform Cloud account, if for nothing else than using it to do your remote state management, as Welly showed. At least it means that the dog can never eat your homework, because that's on us to being responsible for making sure you have your states. Also, there is this QR code. Please go and register. We're going to run a Terraform on AWS hands-on lab. So in that scenario, you'll actually get real hands-on time to actually go through and work through the labs, see some actual practical, or take on practical examples of this yourself. And with that, that's all of the formal presentation from Welly and I. I don't know. I'll hand it back to Winston if we have time for some Q&A.
Thank you, Dave and Welly, for a great presentation and demo. We did have a number of great questions in the Q&A panel, which Dave, you've kindly answered. Maybe I just pause for a second and just see if there's more questions coming through. We did have one actually. Yeah, there was one earlier that we missed. I was going to bring up towards the end, and maybe this is one for Welly to kick us off. Is from Prashant, and the question was: Isn't Terraform Landing Zone rebranded to Account Factory?
Yes, great questions. I think Dave kind of entailed this as well. Like a landing zone itself has, like we use that terminology a lot, and that's including it like a product branding as well. And in some cases, it's also the terminology of concept itself. Specific for these presentations, the landing zone in here means that the well architected, like a multi-account environments in AWS, which meant for like a starting point for you to deploy your workloads and applications. So coming back to that key concept, like a blueprints, right? The idea in here is that the landing zone provide that baseline for you to get started. So you have your identity, access management, governance, security, network design, and logging, and all with the codified best practice, put it into the blueprints or like a, in this case, Terraform modules. So this is the meant of the landing zone per se. Yes, the Terraform landing zone as a product kind of evolved into Account Factory for Terraform. That's recently launched on the reInvent. Also highly recommend to kind of check that if you are interested to learn more about it. Do you have anything to add to the landing zone?
Yeah, I think the key part is that definition between them. So the account factory or evolution of AWS Landing Zone into account factory is around how does as a service provide a managed element that can deliver an outcome for you as quickly as possible. What we're talking about in terms of blueprints or patterns, hence why I kind of pivot into that name, is around how you build specific golden images or golden content or standards-based elements that are written in a way, as we said, that extract the variables out, so that could be so they can be reused in a pipeline or in a delivery mechanism that you are either creating the uniqueness by those variables by hand or as part of an automated process. So something that we didn't touch on is there's an element called auto.tfrs, which is a file that actually will write values into the variables. So once you've extracted the variables away, you can then have a pipeline that creates just the uniqueness, feeds that in, do what we already did and work through those workflows, and then you have unique values propositioning it into that module as well. So again, thinking about it from that, how do I make this as reusable as possible to deliver my outcomes as quickly as possible, quickly and easily as possible, and at scale. Any others, Winston?
Yeah, there was another one here from Alexi Zilber. Do you guys have examples for best practice Terraform AWS cross-account user role setup? There's a few guides online, but I can't find an official HashiCorp one. Perhaps a reference to a link or something we might have?
Not off the top of my head, but it's probably something that we can probably get back to in terms of following up. I know there is a couple of examples. I think there's even one in those in the Terraform modules on AWS page. Now that page is actually a part of the AWS quick start guide. So if you remember being longer in the tooth, I was used to use that quite heavily, that quick starts guide. The Terraform modules on AWS are actually part of that that guide page. So if you're used to it, go in there, you can actually find your find that guide there and leverage some of them.
Excellent. And probably time, just there's two more here. I'll just quickly fire them off to you, gentlemen. Is there a trial version for Terraform Cloud?
Yes. So once you log in, you'll get a free upgrade trial. You can click it. You can go and self-serve easily.
Excellent, thank you. And last one here is, what are the limits to the free tier of Terraform Cloud?
So the limits are more around the governance and compliance. So everything that's been shown here that either Welly or I have driven, you would be able to do. So using the free tier, using the trial tier, sorry. If you wanted to, please engage with a HashiCorp representative, and we can. There are the ability to then set up full trials for for whatever you want to do and prove out your business case. So we're always happy to work with you around engaging technically to try and drive that.
Fantastic. Thank you, Dave. So we've got a couple of minutes left. I just leave the floor open just to see if there's any other further questions coming through. Okay. All right. Well, folks, looks like that brings us to the end of our session. Hope you found it useful. As mentioned earlier, and Dave mentioned, the webinar has been recorded. We will make the recording available on our website very soon, and we'll also send out an email to everyone that has registered with a link to the recording. If you like what you heard today, you want to learn more about Terraform on AWS, encourage you to check out our Learn pages on our website. Dave, I might get you to quickly just flash back to the QR code on the previous slide. Yeah, perfect. So yeah, if we miss any questions or there's anything else that you think of post session, please use this QR code to access the feedback form. We'd love to hear from you. We'll be running hands-on workshops, as Dave mentioned, down the track as well. So keen to garner your interest there, and we'll share the dates and session availabilities later in the piece. Alrighty, well, thank you for joining us today. Big thank you to our presenters, Dave and Welly, and enjoy the rest of your day and see you next time. Thank you.